I'm Jim. At JSmotorsport, we're going to show you how to build a Norton racing motor. Start with balancing the crankshaft. This motor uses a short stroke crank. So we're going to weigh the piston, the ring set, the circlips, the small end of the rod, and the pin. Notice that this pin is taperboard to save a few grams. This is the reciprocating weight, and it's what causes all the stress and vibration in your motor. So you want this to be as lightweight as possible. We want a 65% balance factor. So we're going to multiply the reciprocating weight times 65%. Then we're going to add 100% of the rotating weight, which is the big end of the rod, the shell bearings, and the oil in the crank, which is anywhere from 25 to 50 grams, depending on the crankshaft. This flywheel has too much counterweight, so we're going to reshape the flywheel and rebalance it. Sometimes it's good to make a plug that goes in between the journals. That way, if you take too much off the counterweight, you can drill a hole in the plug and balance the two out. Then when you're ready, Loctite the plug into place, bolt everything together. If you want to balance it yourself, get the Norton Race Manual. It has instructions and illustrations on how to static balance your crankshaft. This is a Norton racing crankshaft. It's been nitrided. If you ever grind the journals, you have to re-nitride it or it'll break. These are heavy-duty racing cases. We're mounting a one-way reed valve breather. The one-way reed valve breather works more efficiently if you plug these vents to the timing chest. We've relocated the oil return hole here so the oil level is lower and you don't churn up so much oil. This is a vertical engine. If it's a tilted engine, you can relocate that oil return hole down here. First thing we're going to do is shim the end play of the crank. Don't use the small shims because they'll ride on this radius on the crank stub. Use the large shims that go in the cases. The easy way to shim the crank is to take some junk bearings, belt sand the outside diameter down so it's about 3,000 smaller. That way they'll easily fit in and out of the cases. You can do the same with the inner race. Use a die grinder, open up the inside about 3/1000 so it'll slide onto the crankshaft. You want about 5 or 10/1000 of an inch in play for the crankshaft. You can use a dial indicator or you can install shims till you have zero clearance and then remove some shims. You want the same for the cam end play. And you can just use a feeler gauge between the bronze bushing and the sprocket. We're going to install a JSmotorsport camshaft because it uses lightweight lifters that weigh less than half as much as the heavy stock lifters, and they use the bronze blocks. The lightweight lifters have about a 1 1/8 inch radius. This curvature gives you a better geometry than a flat lifter or a lifter with a broader radius. The improved geometry of the small radius lifter allows you to use a cam with a broader, smoother nose. This spreads out the stresses and gives you a longer lasting cam than a stock cam with a sharp pointy nose that creates more stress and wear. These are high quality rods made for JSmotorsport by Carrillo. There's no bushing. That makes the small end about 30 grams lighter than other steel rods. The bolts are very high quality. They're good for life as long as you don't over torque them. You torque them down to about 35 foot-pounds. If you go over 40, then you've ruined them. This is a DLC coated pin. The DLC coating prevents metal-to-metal contact with the bushless rod. The pin and the rod still look like new after years of service. The shell bearings have been coated with a moly coating. This gives them a longer service life. And we need to do everything we can for this motor because it's going to be a high RPM screamer. As you can see, This rod is longer than a stock Norton rod, and it goes with a shorter piston. That gives you a better rod to stroke ratio, which reduces stress at high RPM and gives you a little more power. The piston is much lighter than stock, weighs about 1/3 as much. You can see we've drilled the skirts because we're taking all the weight we can off this for the high RPM. There's a coating on the skirts. It's abradable and it'll wear off at the tight spots. After it's broken in, you end up with a tighter piston overall than normal. Before you assemble the cases, temporarily install the camshaft, the lifters, and the lifter blocks. That way you can check the alignment of the camshaft lobes to the lifters. You also want to check the clearance between the lobes and the lifter blocks. This gap here should be about 40 or 50 thousandths of an inch. Now with the cylinders removed and the lifter blocks still in place, you can see that they protrude about 40 thousandths of an inch here. Record that measurement for later. If you have too much camshaft in play, say 20 or 30 thousandths, then you'll want to use a shim to take up the slack. Check the cam lobe alignment with the lifters to determine whether the shim should go inside the case or outside the case. If you put it outside the case, then you'll want to use some contact cement and glue the shim directly to the case. Otherwise, the shim can fall down and get caught between the cam shoulder and the sprocket. Now we're ready for assembly. We're going to heat up the cases to about 250 degrees, put the bearings in the freezer, drop them into place. Do the same thing with the crank. Chill down the crank, warm up the inner races. It's good to have aluminum bar and a piece of tubing on hand in case you need to tap in the super blends and pound on the inner races. The bearings and shims are in place. We're going to lube them up, squirt some oil in the cam journals, and prime the crank. Use an oil can and squirt oil into the oil hole until you see it coming out the journals. Also use a little bit of assembly lube on the journals and on the cam lobes. Doesn't hurt to put a little bit on the cam journals as well. Everything's ready. The rods are torqued down. It's all lubed up. Use a thin smear or Permatex Moto Seal 1 or the right stuff. Put a thin film on each mating surface. Assemble the cases.